Hey guys, here's a quick video showing you how to find the arc length and also how to find the area of a sector. We'll start out by doing arc length, but in order to even do that, we need to kind of remember how to do circumference. Circumference is obviously the distance around the entire circle, and arc length is going to be sort of a portion of that circumference. So let's just review circumference real quick, make sure we're all good. Find the circumference of a circle with radius of 6. All right, 6 centimeters, so circumference is 2 pi r. So obviously that'd be 2 pi times 6, which is 12 pi. In this case, it's centimeters. It does say round to the nearest tenth, so I'm going to go ahead and put that in the calculator and just let the calculator kind of do all the work. I will actually use the pi button. I prefer it. And to the nearest tenth, that's about 37.7. So 37.7 centimeters. And there's your first basic example doing circumference. You've probably done that before. By the way, if you happen to use 3.14 instead of the pi button, it's not a big deal. You'll see you get something very similar to what we got anyway. Okay. For the second question here, the second example, circumference of the circle is given, right? That's the actual circumference, and they want us to kind of work backwards and figure out the diameter. So we still use the same formula. Circumference is 2 pi r. And to figure out the radius, we just kind of plug in for the circumference and kind of back solve for the radius. So we're essentially going to divide both sides by 2 pi. Divide both sides by 2 pi. You can do it separately if you want. You could divide by 2 and then divide by pi. I'll just do it in one shot. So the radius is going to be about 24 divided by 2 pi. And I get about 3.8. And this case was also, actually, no, this was inches. Okay, you could double check it. You could plug the 3.8 back into the original, circumference formula. 2 pi times about 3.8, and you'll see 23.87. They said 24. Again, by rounding to the nearest tenth, it's going to be off by a little bit, but that's a very reasonable approximation. All right, so that's circumference. If we want to find arc length, we're going to use sort of this formula that represents kind of the ratio. Okay, the arc length ratios are set up for us where you have the length of the arc divided by the full length all the way around the circle, which is 2 pi r, is equal to the measure of the arc's angle divided by the full 360 degrees. So 2 pi r is the full distance around the circle, the circumference. The length of the arc AB is obviously just the length of, the actual arc. That's what we're going to be looking for. The distance, right? That's the arc length. And so those ratios should be the same. The distance for the arc related to the full circumference of the circle should be the same as the angle of the arc related to the full 360 of the circle. So that's the setup. I actually prefer to write it this way because it already has the arc length sort of solved for. And as you notice, the only thing that really changed is they multiplied both sides by 2 pi r in order to get that equation. So you see it's really the same thing, but kind of simplified in a way. So you'll see me typically write it this way. However, if you want to write it this way and cross-multiply or however you want to do it is totally fine, but they are equivalent. So for example, find the length of AB. Now, for some of you, if you looked at this rather quickly, you might have just written 50 degrees. But that's not the length, that's the actual degree measure. So if I want the length of this arc, I'm going to say, all right, the length of AB is going to be equal to, and again, you have it up here just in case, but it's the measure of the angle out of 360 times the circumference, 2 pi, in this case, times 5. So what this part is basically doing is it's giving you like the portion of the circle that you want. We want 50 3/60ths of the circle, right? 50 out of 360 of the circle to get this arc. The full circle is 2 pi r. So this fraction of that circle gets me the arc length. For example, what if it was 180 degrees? 180 degrees, just imagine it. If it was 180, that's exactly half the circle, right? Well, 180 out of 360 is 1/2. So you'd have 180 out of 360, which is 1/2 of 2 pi r. So think of this as like a portion. What portion of the full circle do you want? I want 50 360ths of the circle because that's the angle that I've got. This is 50 degrees. So now I just let the calculator do the work. 50 divided by 360 times 2 pi times 5. I just do it all in one shot. You can do it separately if you want. I like to, when you got the calculators that can handle it, I just go ahead and do the whole thing in one shot. So this is going to be about 4.4 if I'm rounding to the nearest tenth, and that's going to be centimeters. So 4.4 centimeters is a portion of the full circle. 2 pi r, 2 pi times 5, the full circle is about 31.4. So I have about 4.4 out of 31.4 of the full circle, which is about the same as 50 out of 360. Right? If I were to do 4.4 divided by 31.4, that's the fraction of the circle I have. And if I do 50 divided by 360, that's the port. It's almost about 14% of the circle. 50 degrees is 14% of the full circle. 4.4 centimeters is also 14% of the circle. One is angles, one is length, and that's the key difference there. Okay, so there's your first arc length example. And we'll go ahead and do another one here. And then that should probably be enough to get you going on arc length. All right, so for this one, they actually give me the length, and they want us to find the circumference. So again, we know the formula. The arc length is going to be the 60 out of 360 of the full circle's circumference. Well, the arc length is 3.82. 3.82 is going to be equal to 60 out of 360 times the full circumference. Now, what you could do is we could solve this for r and then plug it back into the circumference formula, or just realize this is the circumference formula. So actually, I could rewrite this equation just to make it simpler, 60 out of 360 times c, which is the circumference. So I didn't really change anything, I just rewrote it so that I don't have to solve for r and then plug it right back into the same equation. And now I'm just solving for c basically. So either I can divide this out, I can simplify the fraction, or I can just multiply by the reciprocal. Okay? And some of you noticed, it's just 1/6, so this is really just multiplying by 6. But in case you didn't notice that, it's not a big deal, whatever works. So on the calculator, I'll write it that way. I'll do 360 divided by 60, and then I'm going to multiply by 3.82, which is, there's the 6 that we talked about. So the circumference is going to be about 22.9, it says not nearest 10, so 22.9 centimeters. Okay, so again, no matter what they give you, it's still the same basic formula. You just have to kind of figure out the piece of the puzzle that's needed. And I think that'll be enough to get you going for the arc length kind of problems. If you have any more questions, obviously feel free to ask, and I'll see you in the next video.